Hello viewers, welcome back. In this video we're going to discuss how to delete a node from a given position in a linked list data structure. Say I have a list with 5 numbers. I'm gonna set the first node's position as 1. We can use 0 based indexing also, but I'm gonna start from 1. Let's have the second node position number 2. Let's set the third node having position number 3, 4 and 5. Say the user want to delete a node at position number 4. What we need is a pointer to the node, to the previous node of the target node. In this case we need a pointer to position number 3 or a node having number 30. To do that, I will start looping from the beginning of the linked list and go all the way to position -1. Say the user entered position as 4. So I loop up to position 3, then I'll stop looping. Once I got a pointer to this node, which is the previous node of the target node, let's call it temp. Then using this temp pointer, I can set this temp's next pointer point to the node after the target node, which is this node. So instead of 900, I will set the temp.next is store 400. Where I can get the memory address 400? I can get this memory address 400 from temp.next, which is this node, .next, which points to this pointer of the target node. So let's write code for that. First I'm gonna maintain a pointer. Let's call it temp pointer node temp. Initially it's going to point to head or the beginning of the linked list. Then again I'm gonna maintain a counter to keep track of looping. I'm gonna initially assign the counter to value 1, indicating the first element of the linked list. Then I will check while counter is less than position -1, while counter or C less than position -1. If the user enters position as 4, so this expression is going to return 3. While C is less than 3, we go inside the while loop and we just increment or move the temp pointer to the right. Temp equal to temp.next. So first temp points here at the head. While 1 less than 3 condition is true, we set temp equal to temp.next. Temp.next is this memory address or 100. So next round of loop, temp is going to point to memory address 100, which is this node. Then we increment inside the loop, we increment our counter by 1. Then next round of loop, counter becomes 2, 2 less than 3 condition is true. Temp becomes pointing to the next node. Again counter plus plus, count becomes 3. 3 less than 3 condition is false. We get out of the loop and we maintain a pointer to the previous node of the target node, which is this one. Then using this temp pointer, I can easily set this this pointer point to the next node of the target node by saying temp.next, which is this pointer, equal to temp.next, which is this node, this node's.next, which is this pointer. We can access memory address 400, temp.next.next. This way we set this connection, and once we set this connection, so this node's next pointer is going to point to memory address 400, and we detach this pointer. The target node is no longer referenced by any pointer. This becomes eligible for garbage collection, and this way we can delete a node from a given position in a linked list data structure. Let's jump to IDE and write code for this algorithm. I'm going to define a function public void, let's call it delete at beginning, delete at position, position. This is going to accept a position from user. The first thing we are going to do, we will validate the position number, whether the user has entered a valid position or no. What is a valid position? Any number that is within our length of the data structure. Any number between 1 and 5, including 1 and 5, will be a valid position number. If the user want to delete from position number 6, which is greater than size of the linked list, or 7 or any greater number, these are invalid numbers. Or if the user enters numbers that are smaller than 1, say 0 or -1 or any minus number, these are all invalid position numbers. So let's first take care of this by saying if position is less than 1, or if position is greater than this dot len, we just want to prompt the user invalid position and just return the function. Otherwise, if the position is valid, we're gonna maintain a temp pointer, temp equal to initially this dot head. Then I'm gonna maintain a counter for our loops, counter equal to 1, while counter is less than position minus 1. We keep traversing and incrementing the temp pointer to the right, temp equal to temp.next. Once we got a pointer to the previous node of the target node, we can set temp.next equal to temp.next, which is this pointer, point to the memory address after the target node. We can access this second node or the memory address of the node after the target node using the temp pointer, temp.next, which points to this node, .next, which points to this memory address, by saying temp.next. Once we delete it, we will decrement the size of the linked list by 1. There are 2 corner cases to take care before deleting a node at a given positions. Since we have maintained a tail pointer in our linked list, if the user want to delete at position number 5 or end of the linked list, we need to update this tail pointer and have it point to the second node. And also we have maintained a head pointer pointing to the beginning of the linked list. But if the user enters position as 1 or want to delete from the beginning of the linked list, we set the head pointer point to the second node in this case. So let's take care of these cases. But if you haven't maintained a tail pointer in your linked list, you don't have to worry about this corner cases. Okay, before deleting that, I check if position is equal to 1. We just call our delete from beginning function. We don't have to write the code for it again. If you guys haven't watched the delete from beginning function, what it's going to do, it will delete the first node and it will update the temp pointer point to the second node. Or if the user want to delete from end of the linked list, we need to update our tail pointer also. If position equal to this dot len, we call our delete from end function. We again don't have to write all the code again. If you guys haven't watched this video, please watch that. This is going to update our tail pointer also. I think our function is done. Say I want to delete a node from position number 3, so I call list.delete at position. I want to pass position 3. If I run my code, number 30 should be gone from the list. Oh, again we forgot to increment our counter here, otherwise we get exception, counter ++. Also, once we delete it from end of the linked list, we don't want to delete again, we just want to return. If we delete it from beginning of the linked list, we also just want to return. We don't want to calculate and delete a node again by doing all these lines of codes. Let's run again the code. Number 30 is gone. If I want to delete from the beginning of the linked list by passing position as 1, it should work. Position equal to 1. Yeah, first element is gone. This way we can delete an item from a given position in a linked list data structure. Thank you guys for watching. If you haven't subscribed to Code with Cougar, please consider subscribing for further software engineering and computer science videos, and see you in the next video. Bye bye.